On a grey afternoon in November of 1943, a German test pilot walked across a cold concrete apron toward an enemy fighter that looked like a bad joke. That moment and what he discovered in the next 90 minutes would quietly predict how the air war over Europe would end. Before we dive into his story and into the cockpit of that machine, if you enjoy deep, carefully told histories that reveal how engineering decisions can decide wars, please consider subscribing and turning on the notification bell, so you do not miss the next chapters we are building together. The date was November 10th, 1943. The place was Rechlin, the primary test facility of the German Air Force, a secret laboratory where new aircraft were pushed, measured, and judged. Parked on the tarmac was a freshly captured American Republic P-47 Thunderbolt, brought in only 2 weeks earlier. To many German pilots, it was an insult in metal form, grotesquely fat, clumsy-looking a flying milk bottle as they sneered. Its swollen fuselage, gigantic radial engine, and thick legs of landing gear seemed to violate every aesthetic rule of German fighter design. Those attitudes had been shaped long before anyone at Rechlin laid a hand on the Thunderbolt. Intelligence briefings and pilot gossip described American fighters as crude products of an assembly line, culture-heavy and unsophisticated machines that relied on huge engines instead of elegant aerodynamics. The P-47, according to those reports, was the perfect example of this supposed crudity, a sledgehammer built by a nation that made refrigerators and automobiles better than it made fighters. German aircraft such as the Messerschmitt Bluff 109 and the Focke-Wulf 190 were praised as precision instruments sharp and finely balanced the natural tools of elite airmen. Hans Lurch, the man walking toward the captured Thunderbolt, was about to discover how wrong that picture really was. What he would find in the P-47 was not primitive engineering but something far more dangerous, ruthless practicality. The Thunderbolt was not designed to flatter individual aces. It was designed for armies. It did not exist to break speed records or to impress visiting officials on a sunny test day. It existed to break enemies through sheer numbers and relentless availability to be there again and again when the next mission came. In less than an hour and a half, Lurch would sit at his desk and write a report that calmly laid out this uncomfortable truth. That report would be read, discussed, and quietly placed in a file. The system would ignore him, but history would not. Because at the heart of his assessment was a simple contrast. Germany was building fighters for individual excellence. America was building fighters for industrial war. In a total war that demanded constant operations, that difference would prove decisive. To understand why Lurch saw what others missed, you have to know who he was. Born in 1916 in Breslau, he grew up in modest circumstances, far from any glamour of aviation. As a teenager in the early 1930s, he found his way into glider clubs, learning to ride the wind with aircraft that had no engines at all. It was a hard school. Every takeoff, every landing, every thermal was a lesson paid for in sweat and bruises. He advanced not because his family could pave the way, but because he refused to give up. When Adolf Hitler took power and Germany began to rearm in secret, those skills suddenly had value. Aviation expanded behind closed hangar doors, and the young glider pilot from Breslau found doors opening. By 1939, as Europe slid into war, Hans Lurch had become a test pilot at Rechlin, a role equivalent to being a senior test flyer at Wright Field in the United States or at Farnborough in Britain. Unlike frontline pilots who flew one or two types of fighter over and over, Lurch flew everything that came through the gates. Over the years, his logbook would record more than 120 different aircraft types. German prototypes, production fighters and bombers captured British and American machines, even Soviet designs. He was not just a pilot, he was a trained aeronautical engineer, and he wrote about each aircraft with the cold, precise language of a technician who cared more about truth than about pride. When a German fighter was not good enough, he said so. When an enemy design did something better, he wrote that down as well. That honesty made him enemies. Some party officials and senior officers preferred optimistic reports that fit the myth of inevitable German superiority. Lurch's blunt assessments were uncomfortable reading, yet he was too valuable to dismiss. Again and again, the system chose to tolerate his pessimism because his test flying kept revealing facts that could not simply be wished away. If Hans Lurch said an aircraft was dangerous to fly or brilliantly designed, people listened even when they resented the verdict. The P-47 sitting on the Rechlin tarmac had its own strange path into German hands. 3 days before Lurch's walkout to the flight line on November 7, 1943, Lieutenant William Roach of the 358th Fighter Squadron, 355th Fighter Group, had taken off on an escort, a mission over occupied Europe. Bad weather rolled in. Navigation became uncertain. The flight drifted off course, and fuel gauges began to sink toward empty. One leader crash landed on a beach. Another pilot bailed out into the cold waters of the North Sea. Only a single aircraft clawed its way back to England. Roach, desperate and low on fuel, spotted what he believed was a friendly airfield in southern England. He brought his P-47 down, rolled out safely, and followed a ground vehicle toward a parking area. He shut down the engine, perhaps feeling the first wave of relief. Then he saw the uniforms. The men walking toward his cockpit were not Royal Air Force mechanics. They were German soldiers with weapons raised. In a single moment he understood his mistake. He had delivered himself into captivity and handed over his Thunderbolt intact. That aircraft, nicknamed Beetle, was suddenly a prize. Allied fighters prowled the skies, hunting anything valuable parked in the open. The German Air Force wasted no time. Beetle was flown inland to Rechlin before American or British aircraft could destroy it on the ground. Once there, ground crews repainted it in German camouflage and marked it T9 plus FK, the code of the famous Circus Rosarius demonstration unit that toured frontline bases with captured Allied aircraft. By the time Lurch walked up to the Thunderbolt, he had already heard the jokes. Fellow pilots dismissed it as an overfed, overpowered brute, a caricature of American engineering. Too heavy, too big, too American. In their minds, it embodied everything wrong with the enemy's design philosophy, brute force in place of finesse. But Lurch had flown enough British and American machines to know that their engineers were far from foolish. When they made something that looked strange, there was usually a reason. His first close impression was dominated by sheer size. The radial engine at the nose was a metal mountain, the fuselage behind it, a barrel built around that power plant. The landing gear legs were thick, almost agricultural, with big wheels and sturdy struts. Next to the thin, almost delicate stalks of a Messerschmitt Bf 109 or the compact lines of a Focke-Wulf 190, this thing looked as if a shipyard had tried to build a fighter. Then Lurcher started to look past the outline and into the details. He ran his eyes along the seams and noticed how clean the welds were. Panel gaps were even and tight. Fasteners were uniform. The untreated metal in service areas showed no sign of sloppy finishing. These were not the marks of a crude factory that only cared about speed. This was sophisticated mass production, the ability to build thousands of identical machines to a standard that German factories, increasingly starved of skilled workers and high-quality materials, were struggling to maintain. He climbed the ladder and dropped into the cockpit. Immediately he understood why many German pilots hated it. Compared to the cramped office of a Messerschmitt Bf 109, this cockpit felt enormous. There was space on either side of the seat. The sidewalls did not crowd his shoulders. A pilot used to feeling his aircraft fit him like a tight glove would feel exposed and disoriented. At first glance, that emptiness looked like bad design. The more Lurch settled in, the more he realized it was the opposite. In the Bf 109, he had to crouch to avoid banging his head on the canopy frame. Long missions left his back aching and his legs cramped. Instruments were crammed together, some partially hidden by others. German design philosophy had always accepted pilot discomfort as a fair price for performance. The P-47 cockpit told a different story. The seat was thickly padded. There was room to stretch a leg to shift position after hours in the air. The clear bubble of the canopy gave excellent visibility in every direction. This was more than adequate. It was intentionally comfortable. When he studied the instrument panel, another surprise appeared. Many gauges were marked not just with numbers, but with colored arcs. Green segments showed safe ranges. Red lines marked danger. A pilot did not need to read the exact oil temperature or manifold pressure in the middle of a hectic mission. A quick glance told him whether the engine was happy or in trouble. It was a simple addition, almost childish in its obviousness, but it was brilliant under stress. Lurch thought about the composition of American fighter units. They included free French pilots, Polish pilots, exiled airmen from occupied countries, sometimes men whose English was basic at best. For them, colour meant more than text. Green meant good, red meant stop. The system worked across language barriers. German instruments, by contrast, demanded that the pilot know exact numerical limits and constantly compare those to moving needles. The P-47 treated the pilot as a human being first, an engineer second. The rest of the cockpit confirmed that idea. The throttle mixture control and propeller pitch levers sat together under the pilot's left hand in a natural cluster. Fuel system controls were clearly labelled and grouped. Nothing was hidden behind an awkward reach. The whole layout seemed designed with an average pilot in mind, someone who might be tired, frightened, or only recently graduated from training, not a seasoned expert with years in the air. By late 1943, Lurch knew Germany no longer had the luxury of training only such experts. In the early war years, Luftwaffe schools produced aces, men with many flying hours before they ever fired a shot in anger. Now fuel shortages bit deep. Trainees received fewer and fewer practice flights. They were rushed into combat in high-performance aircraft that punished the slightest mistake. Germany needed machines that could forgive inexperience, but it continued to build fighters that assumed mastery. When Lurch opened the P-47 flight manual and ran through the pre-flight checklist, another contrast appeared. The American text was written as if the reader knew nothing. Every step was spelled out. Switch positions, sequence of actions, expected indications, all laid out in clear, simple language. German manuals often assumed that the reader was already familiar with the logic behind the systems and only needed reminders. Here the manual treated the pilot almost like a beginner. It was not an insult, it was insurance. Then came the moment of truth. Lurch followed the instructions, primed the fuel and hit the starter. The Pratt & Whitney R2800 double wasp at the nose of the Thunderbolt coughed, caught and rolled into a deep, even roar. There was no stumbling, no coughing fit, no long ritual of coaxing. The big radial settled into a smooth idle that sent only the faintest tremor through the airframe. Lurch had flown enough American aircraft to recognize a pattern. Their engines tended to start easily and run with an almost unnerving smoothness. Late war German engines were a different story. Manufacturing quality varied from plant to plant. Parts from different factories did not always match perfectly. An engine that ran beautifully on its first test flight might develop rough spots or worrying noises after only a few hours in service. Wartime shortages and hurried production were taking their toll. Sitting there behind the humming R2800, Lurch understood that the real miracle was not building one excellent engine in a carefully controlled laboratory. Almost any advanced nation could do that. The real miracle was building thousands of engines that all behaved like this one, that started predictably, idled cleanly, and tolerated rough handling by line mechanics. That was what American industry was doing. German factories, under bombing, short of skilled labor and squeezed for materials, could not match that consistency. As the Thunderbolt vibrated gently around him, with instruments reading deep in the green and the big propeller turning like a metronome, Hans Lurch realized that he was not just sitting in an enemy fighter. He was sitting inside a different way of thinking about war. And when he released the brakes and began to move toward the runway, he was about to find out what that philosophy felt like in the sky. The Thunderbolt rolled forward, heavy but sure-footed. As Lurch eased it along the taxiway, he could feel through the seat and rudder pedals that this was not a nervous thoroughbred, but a broad-backed animal that liked to keep its feet on the ground. The main gear sat far apart, the struts thick, the tailwheel locked firmly into line. With the canopy offering good forward and side visibility, he could actually see where he was going instead of peering around a long nose the way Messerschmitt pilots so often had to do. Every bump in the concrete reminded him that this machine had not been built only for polished bases like Rechlin. It was clearly meant to survive rutted, muddy strips much closer to the front. In his mind, he compared this experience to the countless starts he had made in the Messerschmitt Bf 109. That fighter with its narrow undercarriage and high nose always carried a hint of catastrophe. A small lapse of attention, a gust of crosswind, or an over-eager application of power could suddenly swing the aircraft into a ground loop. Many machines were damaged or destroyed in such accidents with no enemy in sight. The Thunderbolt felt different from the first meters. It tracked straight. It did not threaten him. For a pilot with only a handful of hours in type operating from a rough, improvised airfield, that difference could mean the difference between an operational fighter and another wreck pushed off the strip. Later in his memoirs, Lurch would recall one moment in particular that drove this home. On a subsequent flight, he forgot to lock the tailwheel, a basic step in the checklist. In a Bf-109, such a mistake could easily have led to a violent swing and the collapse of the landing gear. In the P-47, he felt the aircraft begin to wander, caught the movement and corrected. The fighter forgave him. That forgiveness was not an accident, it was something that had been engineered into the airframe. Reaching the end of the runway, Lurch turned into the wind, checked his instruments and slowly pushed the throttle forward. The Pratt & Whitney engine answered like a hammer blow, dragging the heavy machine down the strip with a strong, steady pull. Acceleration was not explosive in the way of a light German fighter, but it was authoritative, a solid shove, rather than a sudden kick. Because of its mass, the Thunderbolt needed a longer run before the wings took over, yet the whole process felt orderly. There were no sudden swings, no sense that the aircraft was about to get away from him. As the airspeed rose, the weight began to lift from the wheels. Lurch eased back on the stick and the big fighter left the ground in a smooth, unhurried transition. The gear tucked away, and the noise changed from a rolling thunder on the concrete to the cleaner note of flight. The critical moments that so often claimed inexperienced pilots in the Bf-109 had passed without drama. From an operational point of view, that lack of drama was golden. Every takeoff that felt ordinary instead of dangerous was one less chance to lose a scarce pilot in a stupid accident. Once at altitude, Lurch began to explore how the Thunderbolt behaved in the air. He quickly confirmed what German pilots had complained about. The P-47 did not snap into turns with the knife-edge agility of a Bf-109 or a Focke-Wulf 190. Control response was firm and somewhat heavy, especially in tight maneuvers. It did not carve tight circles around a point as eagerly as the German fighters could in the hands of a skilled ace. However, what it offered instead was a kind of calm solidity. When Lurch rolled into a bank and pulled, the aircraft responded predictably. It did not twitch or surprise. It went exactly where he told it to go and stayed there. He extended and retracted the flaps, tested the trim, and experimented with control inputs at various speeds. The hydraulic systems worked smoothly with no unpleasant hesitations or pressure spikes. Everything did what the designers claimed it would do, with no need for the little rituals and tricks that German pilots sometimes developed to cope with temperamental systems. There were no hidden traps, no particular speed ranges where the aircraft suddenly tried to bite the pilot. For a test pilot, that might make the flight less exciting. For a squadron commander trying to keep a unit combat ready, it was a dream. As the minutes ticked by, a picture formed in Lurch's mind. The Thunderbolt was not the most agile fighter he had ever flown, nor the fastest at low level. It did not stand at the top of any single performance chart, yet it refused to show any glaring weakness. It was competent in every mode of flight a wartime pilot might reasonably need, and above all, it was forgiving. It behaved less like a racing stallion and more like a sturdy farm horse that would carry you all day across difficult terrain even if you were tired or clumsy. Climbing higher, he brought the turbo supercharger into its proper regime. Here, above 15,000 feet, the P-47 revealed another layer of its character. While many German engines began to gasp in the thin air at high altitude, losing power and becoming sluggish, the double Wasp kept breathing with surprising vigor. The Thunderbolt could still accelerate, still climb, still dive with authority. In a steep dive, the aircraft felt sure and controllable, and the roll rate remained impressive for such a bulk of metal. For nearly an hour and a half, as he tried different maneuvers, the fighter behaved the same way each time. The engine did not falter. The controls did not stiffen unexpectedly. The systems remained obedient. By the time Lurch pointed the nose back toward Rechlin, he understood that ranking the P-47 on a simple scale of best or worst fighter missed the point entirely. He had flown aircraft that were sharper in a dogfight under perfect conditions. He had flown others that were faster at a specific altitude or that could squeeze out a slightly tighter turn. What set the Thunderbolt apart was that it had been built to deliver the same dependable performance on the 100th sortie as on the first in the hands of an average pilot maintained on a muddy field by mechanics under pressure. On approach and landing, the same pattern continued. The wide landing gear absorbed his touchdown with a reassuring solidity. The aircraft rolled out without drama. He felt again how the stable ground handling reduced risk at a phase of flight where many German fighters came to grief. When he shut down the engine and the big propeller coasted to a stop, he sat for a moment in the quiet cockpit, replaying the entire flight in his mind. Every design choice he had seen, from the cockpit layout to the turbo supercharger, pointed toward one central goalkeeping aircraft available and pilots alive. Outside ground crew were already gathering, eager to hear the verdict on the flying milk bottle. They expected jokes, maybe a performance of mock disgust at the overweight American machine. Instead, Lurch climbed down, looked back at the Thunderbolt, and delivered a simple, disconcerting sentence. It was, he said, the best designed operational fighter he had ever flown. The mechanics blinked, confused. To their eyes, it was huge, inelegant, lacking the clean lines of their beloved Messerschmitts and Fokker-Wulfs. The idea that such a brute could be well designed clashed with everything they thought they knew. Lurch explained himself with the patience of an engineer. The P-47, he told them, had not been built to win contests for maximum climb rate or for the tightest turn. It had been built to fly day after day from rough fields with pilots of mixed experience and mechanics of mixed training in weather that was not always friendly and under enemy fire. Judged by that standard, the standard of operations rather than of pure performance, the machine was close to a masterpiece. That evening, seated at his desk with notes spread out before him, he turned impressions into a formal report. As always, he organized his thoughts into clear sections. Under performance, he laid out the numbers as precisely as available data and his own measurements allowed. High speed at altitude, modest speed at low level, very strong dive climb that was good but not exceptional, turning performance that was adequate rather than outstanding, and truly excellent high-altitude capability, thanks to the turbo. Under handling, he described the aircraft as stable and predictable, easy to manage on the ground, forgiving in flight with very good visibility and a cockpit suited to long missions. Under systems, he highlighted the color-coded instruments, the logical grouping of engine and fuel controls, and the solid construction that promised resilience under stress. The engine received its own praise for smoothness and apparent durability. None of this sounded glamorous, but together it added up to something powerful. In the final section, his strategic assessment, Lurch stepped back from the cockpit and looked at the broader picture. German fighters, he wrote, had been created on the assumption that they would be flown by elite pilots and maintained in relatively good conditions. They were optimized for peak performance under ideal circumstances. The P-47 had been created on the assumption that pilots would be average rather than exceptional, that maintenance would be done in the field, and that engines and airframes would be assembled from parts produced by many factories. As a result, the entire engineering effort pointed in a different direction. He spelled out the consequences in plain language. The forgiving handling would reduce training accidents and keep more pilots alive long enough to gain experience. The robust structure would mean that aircraft hit by enemy fire would return home more often, where they could be repaired and sent out again. The reliable systems and intuitive controls would shorten training time and allow units to maintain higher sortie rates. Add to that the American capacity to build these machines in huge numbers, and the Thunderbolt became something more than a single fighter design. It became a weapon for a long industrial war. Lurch concluded that American engineers had not built the best fighter if one judged by pure performance metrics in a test environment. They had built the most operationally effective fighter, the machine most likely to be present and functioning when needed. In the hands of a nation that could produce thousands of such aircraft and keep them supplied with fuel, spare parts, and pilots, that operational effectiveness would count for more than any performance advantage held by German fighters on paper. He knew that these conclusions would challenge cherished assumptions. Nevertheless, he urged as clearly as he dared that German designers and planners begin to treat operational reliability as a primary design requirement rather than an afterthought. Germany, he warned, could not hope to win a long attrition struggle against an enemy that could keep more aircraft in the air more consistently day after day. The only rational response was to redesign future fighters with that reality in mind. The report went up the chain of command. It was read. It was discussed. Then it was set aside. Senior officers and officials dismissed its tone as overly pessimistic. It did not fit the comforting belief that German engineering was by definition superior and that American machines were coarse and clumsy. Official doctrine remained unchanged. The Bf-109 and the Focke-Wulf 190 were the superior fighters, the Thunderbolt, a crude brute that only numbers made dangerous. Reality began to argue with that judgment almost immediately. By early 1944, P-47s appeared over Germany in the kind of numbers Lurch had quietly predicted. They flew alongside bombers shepherding vast formations deep into the heart of the Reich, and they appeared again the next day and the next. German fighters rose to meet them and sometimes shot them down, but the stream never seemed to thin. For every Thunderbolt that fell trailing smoke, another took its place. Frontline Luftwaffe pilots saw with growing frustration how often the big American fighters absorbed hits that would have destroyed their own aircraft only to turn away and climb out engines still running, wings still attached. They might send one squadron of American pilots into captivity one day and the next day encounter an entirely new group sitting in freshly delivered machines. To men who had grown up believing in the decisive power of individual skill and of fine instruments, this relentless replacement felt like fighting the tide. At the same time, the factories that fed the German Air Force were being hammered from the air. Allied bombing raids shattered production lines, wrecked transport links, and forced dispersal into smaller, less efficient plants. Material shortages crept into every corner of the system, forcing substitutions and compromises. Experienced workers were drawn into uniform or killed in air raids, and were replaced by forced labourers with little motivation and limited training. Quality control, once a point of pride, began to fray. On paper, German fighter production numbers continued to look impressive. In reality, many of those aircraft sat unserviceable at airfields for lack of parts or fuel. Others suffered early engine failures or system malfunctions that took them off the line. American units flying Thunderbolts and later Mustangs maintained significantly higher rates of operational readiness because their machines had been designed with that goal in mind from the beginning. Lurch, still testing captured aircraft and new German designs, could see the pattern hardening around him. The Thunderbolt that he had flown at Rechlin was only one aircraft, yet in its wide landing gear, its comfortable cockpit, its color-coded instruments, and its smooth-running engine, it contained a whole philosophy of war. German leaders had chosen not to listen when one of their most experienced test pilots tried to explain that philosophy to them. The sky over Europe, increasingly crowded with American fighters that kept coming back day after day, would continue the explanation in a language even harder to ignore. Beetle, the captured P-47 that Lurch had flown at Rechlin, soon left the quiet test field behind. It joined Zircus Rosarius, the travelling demonstration unit that carted captured Allied aircraft from base to base. At frontline airfields, German pilots gathered around it the way villagers might gather around a caged beast from a distant continent. They watched as demonstration pilots showed takeoffs, dives, and mock attacks. Intelligence officers briefed them on the Thunderbolt's strengths and weaknesses, on how to avoid its dive, and how to exploit its slower performance at low level. German airmen learned how to fight the P-47. What they did not do was redesign their own machines to match its operational strengths. In hangars and briefing rooms, the lesson was presented again and again. This aircraft was stable on the ground, strong in a dive, and able to absorb damage. Yet the design culture inside the German aircraft industry did not pivot. Engineers and officers continued to chase peak performance, new variants of the Bf-109 and Focke-Wulf 190 that might claw back local advantages. The Thunderbolt's forgiving handling, its comfortable cockpit, its bulletproof radial engine were noted as tactical issues, not as strategic signals that a different way of thinking about fighters was needed. The machine toured the squadrons, but the philosophy inside it remained foreign. By the end of 1944, the gap between philosophy and reality had become a chasm. The Luftwaffe was collapsing not because its pilots had lost their nerve or forgotten how to fight, but because the industrial and logistical foundations beneath them were crumbling. Fuel stocks that had once seemed merely tight were now dangerously low. Refinery after refinery had been bombed. Transport lines had been cut. Aircraft could be built sometimes, but they could not be flown often enough to matter. The pace of operations that total war demanded could no longer be sustained. The weaknesses Lurch had quietly written into his report began to show themselves in the starkest possible way. Fighters sat lined up on airfields, their camouflage fading in the weather, not because enemy bombs had destroyed them, but because there was no fuel in the tanks. New pilots arrived from training schools with only a handful of flight hours in high-performance fighters, because there simply was not enough fuel to give them the practice they needed. Scarce aviation gasoline was saved for frontline missions, not for careful instruction. Spare parts once taken for granted became treasures. A single failed engine or damaged undercarriage could turn a usable aircraft into a permanent hangar queen. Through all of this, Hans Lurch continued his work as a test pilot until the war's end. He flew prototypes that never reached frontline units, emergency projects created in panic, and more captured enemy aircraft as opportunities arose. Somehow he managed to do this without ever crashing or seriously damaging an aircraft, an almost unbelievable record given the risks of experimental flying in wartime. His logbook eventually held entries for well over 120 different types, many of them flown with little more information than basic cockpit labels and the instincts of a cautious, skilled pilot. When the fighting finally stopped, Allied technical intelligence teams fanned out through the ruins of the German aviation industry. They were looking for machines for blueprints and for people who understood what those machines could and could not do. In dusty filing cabinets they found Lurch's reports. The blunt language and cool analysis stood out among more optimistic assessments. Before long, the former test pilot found himself sitting in front of Allied officers who had come not to arrest him but to question him. One American officer in particular was struck by the way Lurch had written about the P-47. Most captured aircraft reports focused on climb rates, top speeds, and turn performance. Lurch had addressed those topics, but his real emphasis had been on operational design. The officer pointed this out, noting that it was unusual for a fighter evaluation to focus so heavily on cockpit comfort, maintenance assumptions, and reliability. Lurch did not back away from that focus. He insisted that in a long war, those features mattered more than a few extra kilometers per hour of speed. He explained calmly and without bitterness that Allied superiority in the air had not been the result of a magical aircraft that was always faster or more agile. Allied pilots were brave, but so were German pilots. The difference was that the Allies could sustain operations at a level Germany could not match. They could keep more aircraft flying on any given day. They could train new pilots properly because they had fuel. They could repair damage quickly because they had standardized parts and factories that produced them in huge quantities. Operational design and industrial capacity, not individual heroics, had tipped the balance. To Lurch, the P-47 had made this philosophy visible the moment he strapped in. The comfortable cockpit was not a luxury. It was a tool that allowed a pilot to endure missions that lasted many hours, missions that stretched out over vast distances. The forgiving handling was not a sign of sloppy engineering. It was a deliberate choice to reduce accidents and fatigue. The smooth, robust engine and thick, sturdy structure were not overkill. They were insurance that a pilot who made it through an enemy's fire would actually bring his aircraft home. Every one of those traits, he told his interrogators, translated directly into operational numbers. When Allied officers asked how German leadership had reacted to his report, Lurch could only offer a small, bitter smile. Officially, his assessment had been labeled demoralized. The idea that American engineering could be superior in any dimension offended ideological assumptions about German genius. The narrative of inherent German superiority in technology and fighting spirit was so deeply embedded that data which contradicted it was treated as suspect by default. His report and others like it were seen as weaknesses of attitude rather than as warnings. At one point, an interrogator asked the question that every student of history eventually asks. If Germany had adopted American design philosophy earlier, could the war in the air have unfolded differently? Lurch considered this carefully. By 1943, he pointed out the industrial base of Germany was already far behind that of the United States and the Soviet Union. No amount of clever design could conjure steel, fuel, and factory workers out of thin air. Design philosophy alone could not erase that gap. However, he added a different design approach from the beginning might have prevented many of the non-combat losses that bled the Luftwaffe white. If fighters had been designed to be easier to handle, more robust, and less demanding to maintain, fewer aircraft would have been lost in training accidents or sidelined for lack of spare parts. Pilots would have survived their first months at the front in greater numbers building experience instead of dying in preventable mishaps. That would not have reversed the overwhelming industrial superiority of the Allies, but it might have prolonged Germany's ability to resist. As Allied investigators dug deeper into captured archives, they realized that Lurch had not been alone. Other engineers and test officers had also written frankly about the strengths of Allied aircraft and the weaknesses of German designs under real combat conditions. They too had recommended changes that would improve operational reliability and ease of maintenance. Again and again, those reports had collided with ideological walls. They contradicted the myth of invincible German technology and were therefore set aside or buried. The pattern was not a single man being ignored. It was a whole technical culture being overruled by propaganda. The numbers that emerged from production records told the same story in a harsh mathematical form. The United States built more than 15,600 P-47 Thunderbolts during the war. At peak capacity, one complete aircraft rolled off the assembly line roughly every hour. Germany, by contrast, produced about 36,000 single-engine fighters of all types combined across the entire conflict, and that production was constantly disrupted by bombing and resource shortages. On spreadsheets and graphs, the scale of the difference was undeniable. Yet even those production totals did not capture the whole truth, because they did not show how many aircraft were actually available to fight on any given day. Here the design of the P-47 showed its power again. In a typical American fighter group, with 100 Thunderbolts on strength, it was common to have 85 or 90 aircraft ready for operations at short notice. Maintenance crews could keep them flying because engines were reliable, systems were accessible, and spare parts were standardized. In a comparable German unit with 100 fighters on paper, perhaps 60 or 70 would be flyable. The rest were grounded by mechanical issues, battle damage, awaiting repair, or simply a lack of parts or fuel. When you multiplied the raw production advantage of the Allies by that higher operational readiness and by the ability to train and replace pilots consistently, the result was overwhelming numerical superiority at the point of contact. Over the front lines, this did not appear as abstract statistics. It appeared as 8 or 10 enemy fighters appearing where a German pilot might have expected 2 or 3. It appeared as bomber formations that remained heavily escorted day after day despite losses. It appeared as the sense that no matter how well individual German pilots fought, they were always outnumbered in the long run. In peacetime, Lurch set about capturing his experiences in a book. Luftwaffe test pilot flying captured Allied aircraft of World War II, gathered his wartime flights into a narrative that engineers, historians, and aviation enthusiasts could follow. In those pages, he described in calm detail how it felt to take off in a British Spitfire, a Soviet fighter, a P-51 Mustang, or a B-17 bomber. His chapter on the P-47 included not only performance notes, but also the remark that has been quoted so often since, that the Thunderbolt's cockpit felt like a comfortable armchair compared to the cramped metal box of the Bf-109. What made Lurch stand out was not simply that he had flown so many different machines. Others on both sides had also tested captured aircraft. His importance lay in the way he used those experiences to draw conclusions about industrial thinking. Where many pilots saw only whether they liked or disliked how an aircraft felt, he saw clues to the assumptions its designers had made. He could take a feature like color-coded instruments or wide landing gear and trace it back to a philosophy about who would fly the aircraft where and under what conditions. Beetle, the captured P-47 that had once scared Lieutenant Roach half to death when he realized where he had landed, became in Lurch's memory a symbol of a deeper clash. On one side was a German approach to war that still carried the shadow of World War I, with its emphasis on individual excellence, heroic duels, and the belief that the best machine in the hands of the best pilot would decide the outcome. On the other side was an American approach that treated war as an industrial process to be won by sustained operations, predictable logistics, and the ability to absorb losses and continue. German fighters such as the Bf-109 and Focke-Wulf 190 were in many ways brilliant creations. When they were freshly built, properly maintained and flown by experienced pilots, they could be superb weapons. However, as the war ground on the conditions required for that, brilliance became rarer, manufacturing quality declined, maintenance became harder, fuel and parts became scarce. The gap between the way these fighters performed in ideal test conditions and the way they performed in everyday operations grew wider. The P-47, by contrast, had been built from the outset to tolerate rough handling, rough fields, and rough times. It could take off from primitive strips scraped out of fields in Italy or France with mud under its wheels and maintenance tents flapping in the wind. Mechanics with moderate training could still keep its big radial engine running because that engine had been designed for reliability and because spare parts flowed in quantity. Pilots who had not spent years perfecting their craft could still fly it safely because the aircraft was designed to forgive mistakes instead of punishing them. Looking back, it is hard to avoid seeing Lurch's November 1943 report as one of those uncomfortable documents that history scatters in the path of leaders. It laid out in plain terms a truth that did not fit the story those leaders wanted to believe. As so often happens, the truth was filed and forgotten while propaganda marched on. For the next 18 months, events in the sky unfolded almost exactly as Lurch had predicted, not because he was a prophet, but because he had paid attention to what the machines themselves were telling him. The narrator of this story draws a lesson from that arc which reaches beyond the specific case of the Thunderbolt. In any sustained conflict, whether military, economic, or technological, reliability and availability tend to beat peak performance. The question that matters most is not, what is the maximum this system can do in perfect conditions, but how often can it do enough under real conditions? Design philosophy, the set of priorities that guides thousands of small choices, shapes, that answer more than any isolated specification sheet. By those standards, Hans Lurch was right. The P-47 was not the finest dogfighter of World War II if one looked only at turning circles or raw speed. Yet it may have been one of the best designed fighters of the war because it was designed above all to be present, to be flying when it was needed, to survive mistakes and damage, and to come back for the next mission. In the end, that quiet, stubborn ability to keep showing up is what decided the struggle that played out over the fields and cities of Europe. And it is a lesson that still speaks far beyond the wings of a single, much underestimated aircraft.